Hello everyone! Today we will turn our Arduino into a simple voltmeter with LCD display. For this project we will need two 1 kilo ohm potentiometers, one 300 ohm resistor, LCD display with HD 44780 driver, and plenty of cables. Let's take a look at the display pins. Going from the left we have ground pin, power pin, contrast control pin, pin that determines if data sent to the display is command, for example clean the screen, or text to be displayed. Low state on that pin means that the data has to be considered as command. High state that it is just text. Work mode pin. Low state means recording mode and high state means reading mode. In our project, display will only record data from the Arduino and display it. And because of that, we can connect this pin to the ground. Pin number 6 informs display that some data has been sent. Every command needs quick pulse on this pin to be read. Pins from 7 to 14 are data pins. Through them, commands and text are sent to display. We can use our display in two data transmission modes, 4-bit mode and 8-bit mode. 8-bit mode is faster, but it needs 4 more Arduino pins than 4-bit mode, which is fast enough for today's project. For 4-bit mode, we will use pins from 11 to 14. Pins number 15 and 16 are anode and cathode of the backlight LED diode. For display control pins, I have choose Arduino pins number 2, 3, 4, 5, 6 and 7. Contrast control pin has been connected to the power line through potentiometer acting as a voltage divider, because display contrast is controlled by a voltage on this pin. Backlight diode has been connected to the power supply with the protection of 300 ohms resistor. Power supply of our circuit is Arduino 5V source pin. On the second breadboard, I prepared second voltage divider, which values we will measure. I connected the middle potentiometer's leg to the A5 Arduino pin, because only A pins are plugged into the analog digital converter, ADC. Only those pins are able to measure the voltage. ADC probes the voltage and converts it into integer value in the range from 0 to 1023. Our circuit is ready. Let's take a look at the code. On the top, we have command that includes the liquid crystal library, which contains functions that control display with HD 44780 driver, such as ours. Below, I have defined constant range with value 5, because ADC embedded in Arduino is able only to read voltage up to 5 volts. Don't worry, we will increase that range in the next video. Here we call the constructor of the liquid crystal class and create the LCD object. This constructor needs 6 parameters for the 4-bit data transfer mode. They are Arduino pins chosen for control the display. The order of the parameters is important. As I said before, display pin number 5 is connected to the ground, so it isn't mentioned in the list of parameters. I have defined the variable measured value, which will store the integer values returned by the ADC. Second variable of type float will store the computed number of volts. In the setup function, we call our object's method, begin, which initialize our display, and needs two parameters, the number of columns and rows of our display. Today we are using the 2x16 display. In the loop function, value read by ADC is assigned to the measured value variable. For reading the value from the analog inputs, we are using the analog read function, which takes the number of ADC pin as parameter. In this line, computed value of the voltage is assigned to the volts variable. Method print displays the values and clears the screen before next run of the loop. Delay function eliminates flickering of the displayed text. It is final time to run the simulation. Great! Everything works properly. Let's check out how it will work on my desk. It works very well, and our circuit is pretty accurate. Another great step behind us. But it isn't the end of play with our voltmeter. In the next video, we will increase its measuring range. See you soon. Bye!